I think you started the recording. Shaila, maybe you can start off with the session.
Yeah, I'll start. Hi everyone. Today will be seeing a non-CDC bot. Like it is similar to what Pratyasha had explained you yesterday. The only difference is today we will see a file of a bit. The structure will be varying. So it is a little bit complex structure. So we will have a look into that. Okay. If you see my screen, I'm showing you a board input file where we have multiple headers and details. Whatever Pratyasha was showing you yesterday had only the details. So it was easy for us to create a message set with only one complex type and make that as an unbounded, which means multiple details will be passed by the message set in order for your for you to get it into a character value. So now for this particular board, what will be the scenario is, even though I have a single file header and a file trailer, also along with that I have my individual headers inside. So I will have this individual header, and within that I will have multiple details, and that will be generated as a one single CMM. Just for comparison, I'm telling, yesterday we saw a case. See, you assume this column number 3, only these details we were seeing yesterday. But in our case today, what we are going to see is one single header and multiple details in it, and next the other header and the multiple details in it. So every single individual header will be generated as one single CMM. So for that, what we have done is, I'll show the code how we've done. Okay, the message flow looks the same. We don't have any thing different speaking to about this. The only thing which gets varied is only the subflow. So yesterday you would have seen only one RCD node, and straight away you would have noticed this single ESQL compute node. But here what we are doing is, initially before parsing it, we are removing the file header and the trailer. The reason why we remove this file header and trailer is we don't have any mappings mentioned for the file header and file trailer. So it is not required to create a message set and just keep parsing for the ones which we do not have mapping. So how the logic was handled is, if you see here, the end of line character will be LF. And also I got a confirmation for this particular bot in my 584 position. 1 minute. Okay. In my 584 position, how can I identify my header and detail? By seeing this, I can say 584 position, here it is 1, which means it is a file header, and the next one is 2. If you see in the 584 position, the value is 2, which means it is a detail. So until the next one comes, it will be the detail lines of this particular header. So this was the thing that was specific to only this bot. So the logic may vary for each of your bots. We may not have the same scenario. This is just for an example which I am showing you now. So I'll be creating this one header of this one, and these two indicate 2 detail line items are inside this particular header. So what we do is, this header and the trailer, with the help of this first occurrence of the end of length character, we've removed this particular header. And also we have removed the trailer. We had another indicator for the file trailer which will have triple T in it. So every file, whatever the files which I am going to get from my source, it will have triple T. So with that identifier in my ESQL, I have written a code which will identify the header and trailer, and basically it will just remove the header and trailer for my next parsing. So I don't want to confuse you with the code. I am just explaining what we have done in the code. So that is how we do. And finally, after checking that, after removing that, and we are placing it with just a null character, which means everything, the header and trailer will be removed here. And then we are just checking the length. I am showing an example for you as a fixed length file. So I'm just checking the length of it, and I'm just propagating it. And the next RCD node, what it will do is every single line it will be sent out for that to identify. As I told you that 584 position will be my header, trailer, that identifier. So that I need to again convert it into a character value. Only then I'll be able to identify. So the first message set will do nothing but only send every single line as an individual record. I will show you a message set also. This is the library we have created for this particular bot. So if you see, you can find here two message sets. The first one will be just sending all the records after removing the header and trailer, and the other one will be the formation of the header and trailer. Stop me in middle if you are confused. Okay, this is the first message set where I am just giving one record. So I am just giving it as unbounded. So every single record, I'll be sending it as one single record out of it. So that is what will happen in this first RCD node. And here in this identifier records, what I am doing is, like, I need to have an identifier. See, in Notepad++, it is easy for us to directly go and check the 584 position if the value is 1, 2 or something, so that I can identify my header and trailer. But while in terms of this message set, it will not be able to go and identify directly. So we need at least an initiator which can identify. So what logic we put here is, we are just checking the 584 position here, and if it is 1, what we are doing is we are setting a value as h, which means we are just like giving a string value which will be able to identify by my message set. So similarly, we also have a detail which is 2, and there is one more thing other than detail. For that, I'm giving it as 3. So when this thing happens, every single record here in my see here it will be empty. So when it goes to that particular ESQL node, that H will be appended here, and if it is a detailed record here, I'm going to append D, and then if it's a header record, I'll be appending F. And this is how we send, so that my RCD node will be able to identify that, okay, this is the header record and trailer record, and accordingly those values will be grouped. Let me show you that also. Yeah. So these are the complex types which we have created. So if you see in this order header, you can see the initiator which we are appending. This is the string which we are giving in the ES12 node, so that it will be, those records will be grouped here. And if you see in order details, we will be giving it as D, so that here every records will be grouped, and it will be easy for you to go and identify. Because if you just send all the records at once, you will not know which details are coming under which header. So that is the main intention we did this. And after that records get processed, it is usually, as usual, like how we create a ESQL component, how do you do mapping. Here the logic will be entirely different, so you may get confused. So this is what the logic I just wanted to tell you. Maybe in your case it might be different. Not all the bots which you are going to get, not all will have this scenario. Just an example where in case if you get similar thing like this, you can figure out something how you can do it, and you can make it accordingly. So that is what I planned for the today's session for non-CDC. Next we'll be moving to the other topic. If any doubts, you can ask. If not, I'll hand over to Pratyasha. Okay, I believe no doubts. Yeah, Pratyasha, you can take over.
Okay. All right. So I think we have covered all sorts of file interfaces that we covered. Apart from that, now a very important aspect of the development is the audit framework, which we need to understand. So you must have seen that there was a certain flow which I used to keep, highlighting that it is, as a library reference for each and every interface that we have developed. That was the audit interface. So you see this audit exception subflow. So I'm not going to delve into the details of the development of this particular interface because it's a code which we are not modifying. It has been just developed as a separate library so that it can be referenced in every interface that we develop in future. And the basic usage of this interface, this particular library, is that we are kind of having an audit generated for every message that enters your interface flow that you have created and every message that goes out of it. Apart from that, we are also keeping a count of the number of messages that are generated per input message. And in case there are any exceptions, those are also captured. Now, where this data gets stored into, it goes onto a queue. That queue is again connected to another subflow, which puts the message onto the database. So we have database tables where the exceptions and the audit logs are being maintained. So just to give you an overview of how this particular interface is, how this particular library is being used in any BOD that you develop. So this is like a new flow that has been developed. So under this flow, you can see that there is the input node and there is the Kafka node, and there is this subflow where we are generating the canonical, and it has the eSQL compute node. So before that, we have an audit validate input. We have just, we have this audit exception subflow in our workspace. So we drag and drop it here. So that way you can, access one of the subflows which is under that library inside your flow that you have developed. So audit validate input, which you see here, is basically to monitor the incoming messages from the source side into your publisher flow. So there are a few properties that we configure here for audit validate input. The properties under it are the application name, the name of the application which you have developed, so that, whenever the audit is generated, there would be a column in the database table where the application name would be stored. So since all these values that you see here, they are all columns, either the columns in the database or they define whether the audit would be stored or not. So application name is one of the columns. Then is application description, which basically describes the usability or the functionality of this particular code that you've developed. Then you give a BO name. BO name is the name of the interface that you're developing. I was developing journal entry, so I put journal entry here. If you'll be developing some other interface, you'll be putting that particular name here. And that is the developer's call, what name they put. But it should be in accordance with what the name of the interface is. Keep it in a way that, it is easier to filter and find the audit, because the audit table contains the audit from all the interfaces that have been developed. So the DO name is a very important and a very good way to filter out the audits that you want to see from the entire audit table. So that's why keep this name wisely, and whatever BO name you follow for your interface, wherever this BO name has to be set anywhere else, you put the same value, so that it's easier to filter out the audit or the exception records if they are generated for your interface. So I put the component description. In component description also, the application description can count, because it's just describing a message flow which has been developed inside the application. Component type is going to be PF, which means publisher flow. Component input type is file input in my case. You could have NQ. If you're having an NQ input node, then you can probably put NQ here. And source system name for my case is GL. Whatever source system name is defined for you from your data mapper, you can put that here. Audit required is again a value which does not go into the database as a separate database column, but it's a flag which defines whether the audit will be generated or not. If I put audit required as no or N, then the audit will not get generated even if I put all these values here. So in order to generate the audits, I will have to put audit required as Y. There were certain cases where the audit messages were getting logged into the audit queues. So for such scenarios, we would put the audit required as N, so that the audit flows would not get choked with a lot of messages. That's why this particular flag or property is important. Now, audit source unique ID is also another flag only, which just defines whether you want to store the unique ID for the incoming message or not. If you want to, then you put yes, and the path for the unique ID is going to be timestamp. Similarly, for the target unique ID, if you want to store it, you put yes. The unique ID is going to be the unique ID for the outgoing message from the flow, or the message that is going to the target. And if you want to store it, you put it as yes, and the value that you put here is current timestamp. That's what I use for the unique, for identifying a record uniquely, so that I can look at the timestamp and see that this is yes, a current or a recent record, if I am looking for a message which has recently been posted or recently been generated. So validation required source and target we are keeping as N because we are not using this functionality. So we always put the value of these two flags as N, irrespective of the interface. Storing the source message and storing the target message, again, these are also flags. These flags are given the value of yes or no, depending upon the size of the message that is getting generated. When the message size is small, you can store the source message and target message, but when you go to production, it is always advised that the source and the target message not get stored unless it's a non-CDC interface. When we used to have CDC interfaces, we used to keep this as N, but I guess now we're going to have non-CDC interfaces. So storing the source message or target message in the database table would be a call taken by the designers also. They'll be deciding if the message size is too big, we'll probably avoid storing the source message and the target message. If the target canonical is getting too big, then the target message, storing the target message in the table is going to just, put a lot of burden on the database. Or maybe if the message is too big, it may not even get accommodated on the input queue through which the message is going to the database. So that audit queue may not even have the message put onto it. So that could be the case, and that's why storing the source and the target message is entirely dependent upon the size of the source message and the target canonical getting generated. Then comes the component input name. Here you put the name of the source structure where your message is coming. If it is a queue name, if you have an SQL input name, then you'll be having a queue as a source. And in that case, you put the queue name here. In my case, it was a file directory. So I put the file directory here. Now this directory right now, it has not been created, but this is like a tentative value. So I'll just put that here. Whatever value actually will get created in the Unix directory, I'll put it here. It is just for documentation purpose. Again, this is just auditing. So whatever values you put here, they're going to get stored into a database table only. And that is going to help you track a particular message whenever it enters your message flow, or whenever it creates a certain number of output canonicals. So this is just to track. Even if you put wrong values here, it's not like it's going to create certain kind of an exception, but it is definitely going to make it difficult for you to track a message that entered your flow. So, and then this particular value is important. If you don't put it correctly, then you'll definitely have, error in generation of the, audit. So this is called the queue name, where the audit is being captured. So I just told you that the audit does not go directly into the database. This audit framework or the library which has been created, first of all, you reference it in your flow that you have created. And after referencing it, there is a queue where your audits will go as a separate XML message. And then that particular message is going to go through another flow, which you are not going to, you can consider that as a backend for audit, because you are not going to work upon it, but it has already been developed in the past. It is also an IIB flow only, which put the message on from that particular queue which I've highlighted here into the audit database table, so that you can see that in the table. So whenever you are generating the audit, you will not check them on this queue. They will have reached the database table, which we have for audit and exception capturing. And there you go and check the audit records or the exceptions captured. So I have put the value of the audit queue as the one which is present in the production environment, because in our file we put all the values, or in the code that we develop, we put all the values corresponding to the production environment. But when you create your property files, this particular value is going to get replaced by the value of that particular environment. So if you're doing your deployment, your queue name will become EACDDV.audit.message. If you're doing the deployment in QA, it will become EACD-QA.audit.message and so on. And in production, the value is already here, so that value we have. So that way we can maintain the queue value depending upon the changing environment by putting the correct value in the properties file. Then comes the audit validate output. Here we just put the queue name. That's the only property that we configure, because rest of the properties which are required for the output message capturing have already been put in this particular framework, in this particular subflow. Then comes the exception subflow, where we are putting the host name. Host name again is the environment dependent property. Since in my code I am initially going to put all the production related properties, so I have put IIB PR. For the properties file of dev and QA, I am going to put IIB DV in the dev properties file and IIB QA in the QA properties file. Store message is always going to be Y, because we want to capture whatever exception got generated, whatever exception message got generated when an exception occurred. So we are going to put store message flag as Y. Then we have application name. Again, it is going to be the name of the application that you've developed. The BO name has again occurred here. So it's going to be the same value that you put here in the audit input, validate input, so that your BO name remains constant and you can filter out the messages in the database. Then your input type is file input. Input name is again the source directory. If you would have had an NQ input, then you would put input type as NQ, and you would put the NQ input queue's name in the input name. Then replay rule becomes Y, and max replay count remains 3. These are the values that have been hard-coded for all the interfaces that we develop. These values are going to remain constant. The component name is going to be again same as the application name, and the queue name is going to be again changing with the environment. I am putting the production value in my code. That's going to be acd_pr.exception.message. This is where the exception messages will get, they will get propagated, and through this particular queue, it is going to go into the database via another flow. So queue name is EACD-PR. For dev environment, your dev property file will have EACD-DV. For QA, it will have EACD-QA. So this was the audit framework. Now I'm going to show you the table where the audit and the exceptions are getting captured. If you guys have any questions, you can ask. Okay. So you see this particular table, EDIS message log in the message log schema. So this is the table where we are storing the audits, and you see the table called EDIS exception message in the message log schema. This table is where we are storing the exceptions. So, when I just remove all the, the filters that I've put here, and I'll just show you how the table is. So I'm going to connect to the dev database and show you whatever audits have been captured so far, so I can give you an estimate or an idea of how the messages appear in the table. So I have connected to the dev database. I'm just going to run this query. So you see, there is these values that you put inside your code that you have developed. All those values, they reflect here in the table column. So the component name, it must have been set as this particular value for some flow, so it has come as this. You can see component type. For some of them, it's publisher flow, PF. For some of them, it's AF, called adapter flow. That is something we are not supposed to develop, so it's some different interface. It puts the message from, Kafka the Kafka topic into a table. So that is an interface which is being developed elsewhere, so we are not concerned with that. But that's for the adapter flow. Some of the types are AF. The rest, we are supposed to focus ourselves onto the PF kind of publisher flow or the IID flow. The application name has been put here, whatever application name was configured in the code. The BO name, again, this is a very important aspect which I showed you just now. the one that I put journal entry for my interface, somebody has put customer order for their interface. Input type is file or file input, whatever they had. For input name, they have put the source Unix directory's location here. Then message direction has been defined as input. Whenever your audit valid input is processing a audit message, the message direction becomes input. When your audit validate output, when this particular audit is generating an audit, its message direction becomes input by default. And when this particular audit is generating an audit message, then it becomes message direction as output. So this particular is message direction input. There is another message direction output. So here the output canonical, this is the audit for the output canonical, while this is the audit for the incoming file message that was coming from the source. Source system name was UVL for that particular interface, so that has been put here. Then auditing system value that you see here, this comes by default. This is the functionality of the library that has been created to capture the name of the node that processed the message, the execution group that processed the message, and the queue manager where the message reached further. So these values are captured by default by the library that has been created. You don't have to do any configuration for that. The inbuilt code does that for you. So, and this is the transaction ID. The transaction ID stores the name of the file which you processed through your flow. So whatever file name was processed, like for this particular audit, probably this message was processed. The file name was this, AWES EDIS cust order underscore the timestamp. So this was the value name of the file which was processed by the flow. So that file name has appeared under the transaction ID by default. The message unique ID, again, as you saw, we are putting current timestamp. So current timestamp has appeared here. Probably for this particular interface also, the developer has put current timestamp as the message unique ID. So it's appearing here. The miscellaneous data that you see here, it's an important property which we don't really, you must have seen a misdata property inside the IID compute node that we were creating, where after all the messages were processed, it was getting populated. Let me show you that value. You can see this particular value, this disk data value being set here. Here we are setting the CMM count. CMM count is nothing but the count of the messages that are getting generated from a single source message. So whatever single source message is coming into this particular flow, and however many output canonicals it's generating, so that count is being captured, and then that count is being populated into this miscellaneous data. So this miscellaneous data is going to have that particular value, and that is why it is very important property, because it captures the number of messages that got generated for this one file input. So whatever this file was, it generated one output canonical. So that's why the CMM count has come out to be 1. And then we have the actual message. The actual message again is something which depends upon if you have put the flag store source message as Y or N and store target message as Y or N. So this particular one, the above audit, this, the one on the second position, this was the input audit. And if the store source message was put as N, then the actual message did not get captured. Maybe the store target message was put as Y. So in the out message direction out audit, we have got the actual message or the canonical which was generated captured here. If the developer would have put the actual message as N, then this particular canonical which you see here generated would not have got generated. This would also be null. Then we have flow process timestamp and DB insert timestamp, which is by default being set by the library, and this value is equivalent to the current timestamp of the flow. These are the values that you see in the message log. Similarly, for the exception message, I'll show you. This is the exception message. The exception ID is by default generated by the library. It is something that is not being generated by us. It's just getting generated in a sequential order. The transaction ID is again the name of the file which is being processed by your flow. The component name is again, it has not been, I don't know, the developer for this particular flow might have put it some different way, but component name is going to be the value of the application name that you have put, which I have shown you as the publisher flow name, which I put in my flow. So that would appear under the component name. Similar value would appear under the application name also, because I have put it for my flow. Then comes the BO name. Now see, the BO name for this particular interface, the developer did not put the value, so it's coming as null. So if his audits or his exceptions were not at the topmost position, it would be very difficult for him to track it down using a filter on the BO name. And the best way to filter out the exceptions in audits is mostly on the basis of the BO name that you put. So since for my flow, I have put journal entry. So whenever an exception occurs while the message is being processed through journal entry interface, my BO name would be captured here as journal entry. So I can always, run a query on the exception message table by putting a filter or a where clause on my BO name and putting the name value which I have put there. So I'll put journal entry, and then I can see all the exceptions that have been recorded for the journal entry database flow. So here we have put the BO name, and then we put the input type, which was the 5 input or MQ input, whichever you put in your case. Then is the input name or the source name of the source directory or the queue name, whichever is configured in your case. Then the system value is again populated on its own. It again contains the name of the broker and the execution group which processed your message, and the queue manager where your message reached, if any queue manager is involved. If not, like in the case of file sources, mostly the queue managers are not involved, so queue managers are not getting propagated here. Although I'm not sure why this broker and the EG did not get propagated. I think the message did not even reach the ID flow. I'm not sure what happened. It just failed in the Unix directory itself. Then you have the error code. But more important than the error code which is getting generated is the exception source, and rather not just the exception source, but the exception message. The message that is being captured in the exception column. This is very important because it captures the entire message as to, what exactly happened to the source message that you put, or why exactly an exception occurs. So that entire exception message is captured under the exception column. So exception source is the component inside your application which caused the error. That is the exception source. And the severity level, as I have already shown you, that the level is going to be set as 3. Which is a hard-coded value for every interface. So that has been a fixed value. The error code is something which is being set by default. So error code is not that important, and a value to help you identify the exception. But the exception column is going to be very important because it stores the entire exception that occurred, and whatever reason because of which it got caused is captured inside this particular column. So this column is very important. It tells you why your message failed. And it also, here in the next column, we have captured the message also for which the exception occurred, like which message has failed, so that, you can track it down here, like what message was it that failed and why it got failed. Then replay status is going to be N. Replay count is here 0, where it should have been 3, I guess. RFH user is something which again is a by default value, hard-coded value by the library itself. And the exception timestamp captures the timestamp on which the exception occurs. Again, a value which is going to be equivalent to the current timestamp. And the DB insert timestamp is also the same value. Okay. The rest of the values are not really important, because the most important things which are required in the exception table, which are going to help you to identify an exception, have been covered in the previous column. So this was the exception table where your exceptions will get recorded. Once you start with the development and you start testing it in dev, your flow in dev, and you put a certain message, so either you will get an audit for it or you will get an exception for it. So whatever you get, it is supposed to get captured into this particular table. Either the message log table or the exception table, and that is going to help you to identify if there is any issue, and if not, then your audits will get captured successfully, and you can clearly, by seeing the captured audit, you can understand that your message propagation has occurred successfully from source to target. If you have any questions, we can ask here.
Pratyash Shalabh this side. So what does this replay rule signify?
I have never really, had much utility of this replay rule value here. So I have just put it as per whatever was being developed earlier, but replay rule did not really give me, much utility. So maybe that's why I'm not aware. I can maybe ask somebody else who might have worked upon it. But replay rule is not something that I have really focused on. I have my, concentration more focused on the exception values that are being captured here and the source that is causing them, or the node where the message is failing and whatever message is getting failed. Those are like the three important values which I focus upon. So replay rule, I'm really sorry I won't be able to answer. Shaila, if you know, you can tell, or otherwise you can ask somebody else why the replay rule is important.
Yeah, for any issues, if we are not able to post messages or something like that, like for now, the maximum replay count by default, we are hard coding it as the value 3. So, like, I just heard about it, like, it will be giving 3 times a try. So, 3 tries will be given until you reach, and then the exception will be thrown. This is what the initial discussion, but I think from that, we are not getting any information correctly. So I think that for now we will keep it aside.
Any other questions if anybody else has, they can ask. If not, then we can, Shaila, probably, wrap up the session.
Yeah, Prakash, I'm okay. I think you've covered everything so much.
If nobody else has any questions, let's wrap up the session. Okay. Thank you all for joining.
Thank you.
Thank you.
Thank you. Thank you.